Here we're going to look at the squeeze theorem. We're going to assume that the negative absolute value of x is always less than or equal to x squared times the natural log of x, which is always less than or equal to the absolute value of x. And we want to use that to figure out what the limit as x goes to 0 of x squared times ln of x would be. So we're going to use the squeeze theorem. We're stuck between two functions. One thing that could make the answer very obvious is if we can just plug in. We'll still have to verify, proving with the squeeze theorem, but if we can just plug in and see what the y value is, that would be helpful to know. So let's grab our calculator. Let's do 0 in for both these x's. We'll do 0 squared times ln of 0. And what do you get? 0 squared times ln of 0. You get an error in your calculator. We cannot even plug this one in. That is because ln, you have to only plug in positive numbers. So the domain of ln is all positive numbers. So we can't use 0, we can't plug in a negative number either. So we're going to have to figure out what this limit is by just using the squeeze theorem. So it's something we can't plug in, but we know that our lower part of this, that lower part is the negative absolute value of x. We want to see what the limit of the lower end would be. The limit as x goes to 0 of negative the absolute value of x would be negative the absolute value of 0, which is just 0. So the lowest this could be is 0 for that piece there. And we want to compare it to the highest that this limit could be. So we'll look at the upper end. We'll take the limit as x goes to 0 of the positive absolute value of x, and the absolute value of 0 is 0. So our function here is always bigger than or equal to 0 and less than or equal to 0. So what do you think about this limit then? We would say therefore, which is just these 3 dots in math, therefore the limit as x goes to 0 of x squared times ln of x, it is stuck between 0 and 0. It has to also be 0. So we couldn't plug it in. We got an error in our calculator, but we knew that the y value was stuck between 0 and 0. So that limit that we weren't allowed to take necessarily, we were able to calculate using the squeeze theorem. So therefore, by the squeeze theorem, we can make this conclusion that the limit for that x squared times ln of x would have also been 0.